All right, guys, what's going on, everybody? Welcome back here to another live stream, my friends. I hope everyone is having a great day out there. Glad to have you guys here for another update, my friends. We got ourselves a bit more information for you guys, and yeah, they did extend the risk a little bit to the northeast, as you know, as expected. I personally think with the latest trends and everything like that, I think we might get a little bit more expanded to the northeast here regarding severe weather for Thursday. Remember, this is this Thursday, so there is still a pretty decent risk out there for severe weather from the SPC and all of that stuff. So let me go ahead and bring it up for you guys. But what's up, everybody? Hope everyone's doing good. Let's see who we got here for today. We have, let's see, Mothman. We got ourselves Crystal. We have Misty. We have Tiffany. We have Professional. We have, let's see here, Brent. We got ourselves, let's see here, Haley, John. Let's see, Roadster Jim. We got ourselves Lucy, Supercell. And, oh my God, Proxy coming in with a $50 donation. What? Proxy, thank you so much. Saying thank you in advance for all you do to keep us safe, educated, informed. We're grateful for you. Proxy, oh my gosh, thank you so much, Prox. You really did not have to do that, my friend. That is amazing. Thank you so much, Proxy. That is awesome. Much love to you. And if there's anything I can do for you, Proxy, please let me know. Thank you so much. Oh my gosh, that is so sweet of you. That is super, super nice. So big thank you, Proxy. Once again, appreciate it, and thank you for all that you've done here. Thank you for all the support. You absolutely rock. We love you, Prox. What's up, Clint? Let's see. What's up, Frank? Let's see. What's up, Helen? Let's see. What's up, Duck? What's up, Haley? What's up, Mark? What's up, guys? Hope everyone's doing good. Anyway, so yeah, here's the risk here for Saturday. They did include, like I said, portions out there towards Arkansas now at risk, out there, you know, near Texarkana, Nashville, Murfreesboro. Some of those areas out there, well, Texarkana's, I guess Texarkana split between Texas and Arkansas. Anyways, yeah, so it includes both areas, though. So portions of southwestern Arkansas, even portions of, like, northwestern Louisiana is now at risk here, too. For the Shreveport area is now under the gun for potential severe weather. Also, southeastern portions of Oklahoma, too. Very far southeastern, towards, like, you know, Durant, portions out there by Antlers, Hugo, Marietta, it's Idabel. Some of those regions out there is at risk here now for severe weather probability. And remember, guys, this is for Thursday. This is Thursday coming up here for this week. So once again, SPC did issue a pretty big risk. Like I said, a 15% risk. That's definitely a pretty solid risk, you know, regarding the potential for severe weather come here for Thursday. Anyways, but yeah, let me go ahead and bring you guys over here to models. We're going to take a look at the models and all that fun stuff. So I'm actually going to bring it over to you guys this time. We're not going to change scenes right now. Let's just bring the models over here for a little bit. All right, so there we go. So let me go ahead and line this up. This way it'll be all nice and lined up and stuff like that, so we can see it pretty good. All right, so we're going to pull up. Obviously, HRRR does not go out this far quite yet. I don't think any mid-range models are pulling it up yet, so this is still in long-range support. But yeah, we're going to take a look at the GFS here. We're going to pull up the GFS. I'm going to pull that down just a tad. Okay, so we're going to take a look at the instability or the potential fuel for these storms here. So as you can actually see, let's see here. Starting for, what is this, late Tuesday, early Wednesday, there's going to be a pretty decent abundance of instability available across like Texas and portions of like the southern Midwest. However, there will be a cap which will prevent these storms from really firing. So there's really not too much of a threat here. However, also for late Wednesday, we could actually have some severe storms on late Wednesday. Models do show, or this in particular model really does show a pretty decent amount, a lot of instability available. Here for Wednesday, most of it's capped out though, meaning like I said, storms will be having a hard time to produce. They'll be having a hard time producing if they can even produce at all in this environment. But according to this model, there is a possibility in some breaks of the capping inversion, which will potentially allow for some storms to fire off between these areas here. Let me look at the winds. Lower level winds, I mean, they're not anything special. They're really not. Mid-level winds are, pretty weak, actually. I do think it's possible for, a potential marginal severe thunderstorm to occur in this environment. I mean, yeah, we have enough instability, enough fuel for these storms late Wednesday. This is not for the big threat, guys. This is, once again, big threat's Thursday. We're looking at Wednesday. There's a possibility of maybe still some marginal severe weather, I think. I'm just going to grab a sounding towards, like, Louisiana. We're just going to see what's going on here. I'm going to pull this up and see what's going on. Let's see. Good evening, everyone, in NW16 family. See, fam. Wherever you live, stay safe. Thank you, Proxy. Appreciate it. Once again, we love you, Prox. I really appreciate that. Let's see here. Anything for St. Louis? As of now, no. But we'll watch that area because I think that might be one of the regions we could potentially see some storms. What's up, Carissa? Hope you're doing good. What's up, Roadster Jim? Let's see. Anything for Fort Smith, Arkansas? I mean, we'll keep an eye on that general area. That's kind of the region where we're paying attention to for the possibility of some storms. But anyways, back over here to the sounding here. So, I mean, in the sounding across Louisiana for late Wednesday, once again, this is not the day of the organized severe weather we're expecting. This is the day before, actually. There is enough instability to get storms rolling. I definitely think that's a possibility. But once again, our winds in our lower atmosphere are pretty weak, which will really, not allow for, some efficient organization to occur in those storms. So storms might have a little bit of a struggle trying to produce, but I still think it's possible we could get a few strong to potentially severe storms. I don't think anything tornadic. Low level winds are way too weak really for anything like that. In this sounding, one of the main things I see as a hazard is maybe small hail and some damaging winds. That's pretty much the only hazard I really see in this sounding here for Wednesday. Once again, this was taken across central Louisiana here for 21 Zulu Wednesday on the latest GFS. Like I said, the winds are just too weak in this area. Mid-level especially, very, very weak winds. But instability-wise, I mean, it's there. Also moisture. We have a pretty deep lower level moisture here, mid-60s dew points. That's pretty good for storms, but yeah, once again, the big stuff's going to happen here for Thursday. Now, let's go ahead and work our way down in time here. So, obviously, that goes through. We still have a lot of instability. Look at this. Yeah, so there's a lot of breaks, a lot of pockets here that storms could easily flow through. So, the models, they are showing well over, like I said, the models are showing well over 2,000 joules per kilogram, which you really need only 1,000 to get really decent, organized severe weather going. And the fact we have 2,000, that's a pretty good amount of instability out there. So that's something we need to look out there for. Winds on this event here, at least in the beginning, are not forecasted to be super, super strong in our lower atmosphere. We're going to have to see how this plays out. But honestly, for this in particular time frame, this is 00 Zulu. Or this would be 8 p.m. Eastern, 7 Central. I'm glad the time changes because now I can actually understand this a lot better. So this would be 7 Central here. And right around this time period, you notice how we have like this little kind of golden brown kind of color down here. So this is showing that we have stronger winds in our lower atmosphere. And if we take a look at the instability available, well, it's mostly capped out. It looks like there might be a little bit of a divot, but forecasting to this extreme is still not really accurate. Just given the fact that this model here is once again, it's a long-range model. This model is not really good at high resolutions or anything like that, but this model is just taken for a general overview of what things could essentially look out there for. But anyways, but yeah, I mean, decent lower-level winds. I mean, possibly up to like 40 knots in some areas. I mean, really can't be ruled out. You can see that lower-level jet really amplifies as we work our way over there, kind of towards like 03 Zulu, which would be what, 10 p.m. I think 10 p.m. Central time for you guys. So that is what we're looking out there for. So there will be a decent lower level jet there. It just determines on if that cap is broken at that that point in time. But we'll definitely have to see. Now other things like dew point and stuff like that. I mean, we got some pretty high moisture values. I mean, we have quite a hefty amount of dew points. So this basically just measures our moisture in our lower atmosphere, which is very important for thunderstorms. So you need a lot of moisture to be shot up into the upper elevations of the atmosphere. So as the sun hits, or as the beams of the sun hits the surface, it warms it up. And obviously, that's you can tell because as the sun comes up, obviously the temperature gets warmer. I mean, that's pretty much, I'm sure you guys know what I'm talking about here. So once that surface heats up, it actually, kind of creates an area of lower pressure, which wants to rise. So that warm air is starting to want to rise. And there's a lot of moisture inside of that air, which is very much needed for, developing those storms. So as that warm air rises, it interacts with a cooler atmosphere in the above levels in the atmosphere, above the surface, which condenses and creates these big towers we call cumulonimbus towers, and eventually, could, turn into some severe weather if it becomes big enough. In which, moisture is very important, to really get that strong convection really, and really going. So that in itself, yeah, that's pretty good. So our dew points are there. Overall, let's see, damaging winds, not damaging winds, lower level winds from our jet stream here. They do increase later we go into late Thursday. But it really comes down to the fact of, wow, look at that surface low. Holy cow, dude. Wow, that thing amplifies. That's pretty crazy. But it all really determines on if the fact that, we can still get storms rolling, if the storms are in a non-capped environment. That's kind of what it really comes down to. Let's see here. Can I grab some soundings here in west central Arkansas? Yeah, I can do that for you. Let's see. We're going to pull up a sounding here. So some of this, yeah, so a lot of this is capped environment here according to GFS. Now, GFS has never really been a good model to take a look out there for, regarding if there's going to be a big cap or not, because, usually the mid-range models can determine that a lot better than the long range. So while this model shows a cap, a little bit of an inversion there, but, Parcel might be able to pass through that. While it does show a little bit of an inversion, so the temperatures do get warmer, instead of getting colder as you go up. So instead of, while this model says that, maybe as we get closer to the event, the mid-range models will be like, no, that's not going to be the case, and it's going to be freely to convect. So in this environment here, for this in particular time, this is for 00 Zulu, so this is 7 p.m. Central time for you guys. Our winds here, I mean, there is directional wind shear, and we talked about a little bit about this yesterday. So directional wind shear is, basically winds changing directions as you go up in altitude. So you can actually see how, the winds, they do change about a, 45-degree angle. So they start off as pretty much northerlies, and then they change to northeasterlies. So they do change about 45 degrees. So there is a spin. There is a little bit of a, potential for, I wouldn't say a very, very big likelihood, but there could be some weak tornadoes that could occur in that environment, just given the fact that we do have some pretty decent, directional wind shear there. A lot of instability, though. I tell you that. I mean, there is a lot of instability throughout the atmosphere. Once you break that warm layer there, if storms can get past that, then well, yeah, I tell you what, they could become pretty decent in this environment here. But once again, the only concerning thing here is that temperature inversion, and if storms can continue to pass through that line. So that, like I said, that warm air that's rising. It'll continue to be positively buoyant, meaning it'll go up, it'll flow up, and then once it hits that level there, it'll slow down. It'll either A, slow down, or B, completely stop. But let's just say, hypothetically, if it was able to continue moving, then the vertical velocity would increase as, there's more buoyancy and more instability. And it will hit right at the equilibrium level. That is where we have another temperature inversion, which then that's basically where our boundary between our troposphere, and was it the stratosphere as well? Yeah, troposphere and stratosphere. That's what we call the tropopause. That's basically where the two layers of the atmosphere are. So this is troposphere. This is your stratosphere up here. So yeah, so that's the top of the storm. Bottom line, that's where that's the top of the storm here. Bottom line is, so all of that's how tall your thunderstorm would be in theory. But once again, that's if it can break this cap here. Now, for example, let's say if it didn't, it would only go up to this high, to your LFC, level of free convection. So, I mean, it's kind of a big difference. You got to see how much bigger the storms could get if they did fully convect. But if they didn't, they'll just fall. Essentially how weak the winds are at the lower atmosphere in this level here. So that warm air would rise, and it would slow down due to that temperature inversion, and then it would just collapse on itself and fall back down, which would basically cancel out forces and would completely destroy that potential of that storm trying to develop. But anyways, yeah. So that's what's going on there. I mean, that's just sounding there for you, man. Like I said, the winds, I mean, they are directional, meaning that, there is change in wind direction as you go up in altitude, which is what you need for tornadoes and stuff like that. But, whenever it comes to it, the winds are pretty weak. They're not very strong, about 20 knots in our lower atmosphere, which you kind of need those to be in at least 30 knot range. 30, 40 knots and higher is really where you want you to see, really what you want you to see in your lower level jet. But we're seeing about 20 knots, which is pretty weak. So I think this would be just more of a concern in this sounding here for probably just, I mean, if storms can convect, given that warm layer there, at this current model. Now remember, this is one model, this is one opinion here, this could be completely different than the outcome overall. But yeah, so we're talking maybe damaging winds, maybe some small hail in that storm there. So we'll definitely keep an eye on it. Now let me zoom out a little bit. I kind of want to grab the whole picture of things here. So, once again, this is for 0 Zulu on Thursday. Actually, let's go to 21 Zulu on Thursday. So, you might have noticed something. Well, there's actually CAPE, or convective available potential energy. This is the potential fuel we could have in the atmosphere for these storms. Think of it as the gas in your gas tank for a car. We have a lot of gas, obviously, down in the south towards like central and eastern Texas, Louisiana, Mississippi, portions of Alabama, Arkansas, southern Missouri. But there is a little bit of instability, possibly out there, according to the GFS model. The GFS does show a little pocket of some potentially higher instability, as you can see. Maybe out there by Kentucky, maybe even Ohio and southern portions of Ohio. It's not a whole lot of energy, especially not compared to down south, where you can see that the values are a lot higher. But there is some energy out here, which is interesting. I'm going to grab a sounding across central Kentucky here. Just want to see what's going on up here. Look at the environment. And just kind of see what we got going here. So let's see. Okay, well, that's interesting, actually. So there is a little bit of a warm layer like we were talking about that other sounding we grabbed, but honestly, I think it'll be able to go through. I think, the rising column of air will be able to puncture that warm layer there. So, that parcel will continue to rise up to the equilibrium level. So that's where we have the other inversion, and that's for the top of the storm, basically. So, instability over 1,000 joules per kilogram throughout the atmosphere. That's decent. I mean, it's not a whole lot, but it gets the job done at the end of the day. And, whenever it comes to it here, our moisture, lower 60 dew points, that's pretty good. I mean, that's pretty solid. Lower level moisture, pretty good. And our winds, so this is what we call speed shear. There's two different types of shear modes. We say speed shear and directional shear. So we've already talked about directional shear, which is the change in wind direction as you go up in altitude. Very important for tornadoes and stuff like that, like we talked about. In this case, there's not much directional shear. Most of the winds are pointing relatively in the same direction. You can see these little wind barbs here, mostly pointing east. All throughout the atmosphere. We do have a slight change in wind direction. You can see on the photograph how there's a little bit of a curve. There is a little bit of a directional wind shear here, type of scenario going on, but it's not much. It's more of a speed shear. So speed shear, like I was saying, is an increase in wind speeds as you go up in altitude. So you can see, for example, here in our lower atmosphere, we'll use 1 kilometer for an example. 1 kilometer high, about 30 knots. Okay, we'll go up to 6 kilometers, 50 knots. We'll go up to 12 kilometers, 80 knots. So you can see how the winds are increasing from 30 to 50 to 80. So you see how there is like a bit of a change here. So you can see that the winds are increasing as we go up in altitude. That's very important because what happens is in a thunderstorm, you have just like an engine, you have an intake and you have an exhaust. And you would know if you tied up your exhaust to your intake, the storm would choke out and it would die, or the engine would choke out and it would die. You guys know that, right? Especially my mechanics out there. If you connected the exhaust to your intake, it would be game over for the engine. I mean, it wouldn't want to run because it's, recycling that air. So in a thunderstorm, it's very similar. You have an updraft, which is your intake, that warm air that's rising up into the atmosphere, and you have your downdraft, which is basically your let's see, what was it? I'm losing my mind here. So you have your intake, which is, that warm air coming up, and you have your exhaust, which is that warm air coming down. So updrafts and downdrafts. So warm air rises, it cools down, and it comes back down. And it coming back down, that's your exhaust. It rising, that's your intake. So I want to make something visual for you guys. So since the winds increase with altitude, as we see here, don't mind any of this. So in this environment, an updraft, we would have that warm air that would start to rise, and it would actually start to curve. It would actually start to curve because of how strong the winds get throughout portions here of, like I said, how strong the winds get as we go up in altitude. So for an example, once it hits the EL, that's how high that is going to go, and then it'll fall right back down. So it'll be something like that, obviously. So you have your intake, that warm air that's rising. Obviously, that warm air that's rising, it slows down as it starts, getting towards, the EL, the equilibrium level. And then it cools down, and then it starts to fall back down. So that is that's your exhaust, and that's your intake. So for an example, we'll use this for an example. Say there is no wind shear, okay? Say there is no speed shear. There's, a constant, a constant, wind speed and wind direction in the atmosphere, okay? So we'll say, for an example, is 30 knots throughout the entire atmosphere. So what would happen is your updraft would come up, and then it would go right back down on itself, and it would completely die because, that warm air that's coming up, as you got warm air coming up, it would make a tower to begin with, one of those big cumulus towers. It would make one, it would go up, and then you'd have that cooler air come down, and it would neutralize, forces. And eventually it will just collapse on itself because, it has nowhere to go. So your exhaust and your intake is literally, on top of each other, which you need to separate those. You need to keep your intake and your exhaust away from each other. That is kind of what goes on in a thunderstorm, in which I really wanted you guys to know that. And that's, very important for forecasting, to see how strong our winds are and if those two things can be separated overall. But anyways, that's a little bit of a lesson for you guys today. But anyways, hope you learned something though. I really do. Because it's obviously good to learn something every day, and hopefully I made things a little easier to understand for some of you guys. And like I said, there's a lot that goes into weather. A lot of people just think it's, oh wow, clouds, rain, okay. There's a lot that goes into weather. I mean, look at all this stuff. I'm going to make a whole series on this eventually, on how to read, obviously soundings, how to forecast, stuff like that. I mean, to an extent, of course. Anyways, all right, let's see. Let me get back to some of these comments here. My bad. All right, let's see here. Roadster says Andrew does an excellent job teaching. Thanks, man. I appreciate that. Let's see here. let me look. All right, let me catch up here with you guys. Does either speed shear or directional shear have a greater influence on tornadic activity? Yes, it does, directly actually. So, so for tornadic activity, you'd want both. You'd want speed shear, so you would want winds increasing with altitude. You'd want some pretty strong winds even at your surface. And directional shear, you'd want those winds to start off mostly northerlies. So for an example, we'll use like Dixie Alley for an example. So let me get rid of the sounding here. And let me pull up the SPC's page real quickly. I can just do this. I can use the sidewall to draw on here. Okay, I'll use this to draw on. Anyway, so yeah, you need both. You need those winds increasing with altitude, and you need the winds changing. So and we'll use, like I said, the southeastern coast for an example here. So we'll draw a very, very bad example. So there's Florida, there's Texas, there's the Gulf of Mexico. Okay, so for an example, you'd want those winds in our lower atmosphere to be pulling north, and as we go up in altitude, you'd want those winds to change directions. Almost perpendicularly, which could allow for some strong rotation to occur in the atmosphere, which I'm not going to get too much into it, but it's still why not fully 100% known why this happens, but what ends up happening from what we know is that if you have an environment like this, it creates these horizontal rotating tubes, these like vortices, these horizontal vortices. So for example, let me use this as our updraft, and this is our vortice here. I don't want to use. I want something that can bend. Never mind. You know what? Okay, so you have these, because of this wind, this directional wind shear, and you have this, speed shear. The wind's increasing with altitude, so you have like these rotating horizontal tubes in our atmosphere. And with the normal updraft, so the winds are already doing this. They're causing a bit of horizontal vorticity to occur. And so as this is occurring, you can actually get like a normal thunderstorm firing off, right? You get a normal thunderstorm with an updraft that comes up. And as this is rotating, pretend this is still rotating, you get that warm air that pushes right through this horizontal tube, and it causes it to flex. It causes it to bend like a big upside down U. And what happens is that it's still rotating. And so at this point, it goes from horizontally rotating to vertically rotating, which allows for that rotation to sometimes reach the ground, which would spawn a tornado. So hopefully that makes sense. Hopefully that makes sense there. But that's kind of what goes on. That's essentially what kind of goes on is you get a horizontal vorticity, and you got yourself some you got your updraft. Your that warm column of air rising. And sometimes it'll turn those tubes upright, which will allow for this rotation to continue on the bottom, which eventually, in some cases, could reach the surface and could cause some tornadoes. Like I said, it's still not fully understood why this happens. Like I said, there still is a whole, lot of research going on in the storms here, but it's definitely very interesting on how it works. From what we know, that is what it essentially happens. So anyways, but yeah, that's why directional wind shear is so important to get those horizontal vortices starting to really go. And then of course with any normal storm that would develop with a strong upwards moving air, updraft, that warm air that gets sparked starts rising, would put a kink in that tube there and allow it to go from horizontal to vertical overall. Okay, anyways, so that's that. Let me go ahead and we're gonna go out of teaching mode here for now. But yeah, hopefully you guys learned some pretty cool stuff today. Like I said, I wasn't planning on teaching all that today, but sometimes you got to teach in order to make you guys understand what's going on in this atmosphere. So there's a lot of stuff that goes into it. It really is. Let's see here. Proxy says, thanks for the meteorology lesson, Andrew. My brain is thoroughly wrinkled with new information. I'm glad, Proxy. Obviously that it's like I said, it's definitely good to learn something new every day, of course. And I'm glad that I could help you guys out there. So anyways, what's the difference between El Nino and La Nina? So we're not going to get into that, but that's more climatology. So basically, you have your Pacific Ocean, which is the biggest ocean in the world. At the equator is where this is measured. It's basically an anomaly on, warmer, if temperatures are warmer than usual, or at the surface, I should say. It's an anomaly on if temperatures are warmer than normal or they're cooler than normal, and that's measured at the equator in the Pacific. Since the Pacific is so large, and it basically influences, worldwide weather, essentially. Anyways. All right. Let's see here. And just prepping us for severe weather ahead. I am. I'm actually going to make a video on this, that way you guys can watch at your own time. I know you guys, a lot of y'all joining here is probably like, okay, Andrew, that's cool and all. I don't care how that works. Just, where's the thread, right? I got you. So we'll go bring y'all back over here real quickly, back to the risk area. But yeah, so I'll make a video to that who specifically is interested in seeing all that overall. So anyways. All right, so like I said, right here, this is for Thursday. Once again, Thursday is our main day. This is our threat day. And of course, like I said, right now we do have ourselves, like portions of northeastern Texas here, portions of central northeast Texas, areas out there in northwestern Louisiana, southwestern Arkansas, and even portions of like southern Oklahoma is going to be in the risk area out there for severe weather here come Thursday. I do think it's possible, the day of that severe weather gets here, I do think it's possible that this could shift a little bit more to the northeast. And my support to think that, I'll go and bring up the models again for y'all. Like I said, the models are showing a bit of instability, working its way out, further into the northeast. Wind shear is not the best, but even across that risk area, wind shear is not super, super crazy. Not until later anyways. But yeah, let me go ahead and bring up the instability. Once again, this is basically our fuel. Think of this as the fuel in the atmosphere. All right, so there you go. We can see here for Thursday, 21 Zulu. Let's see, let me move this over here. There you go. 21 Zulu Thursday. This model does show some instability or potential energy for severe weather, or storms, I should say, in general. That could be in place out there towards, Kentucky, possibly like Ohio and some of those regions there. So our lower level winds here at this given moment, let me first of all actually hop back over here real quickly. So let's just say we have a big pile of CAPE here. Now remember, this is one model. This should be taken, with a grain of salt, considering it's one model, one run. I really like to dive into this more whenever we have mid-range models like the NAM that goes out a little closer to, a little bit close, or whenever the storm gets a little closer to the current time period. But let me go ahead and bring up our lower level winds here. So that's where all of our CAPE was, that big circle there. Our jet stream is actually not too bad. We have about 30 knots lower level jet. it's doable. It is. It's not the best lower level jet I've seen. But yeah, the winds are moving in this case from southwest to northeast. So lower level winds about 4,000 feet up are moving from southwest to northeast. So I wouldn't say they're strong, but they're okay. Mid-level winds, wow, actually, look at that. So the winds are actually directly eastward and about 50 knots. So you see this is about 18,000 feet up. So there's your directional wind shear. You guys catch that? So our lower level winds are pointing northeast. Our mid-level winds are pointing east over that area of instability. So you see things lining up here? So that's why I think that we could have a little bit more of an extension here, I think, time come, if models continue to support this. Our dew points as well, upper 50s, lower 60s. That's good enough to get, some severe storms going there. But yeah, there you go. So there's wind directional change. Let me actually just grab a sounding across northern Kentucky here. Just, why not? Let's just see what we got going on here. Let's see here. Okay, so according to this sounding, so yeah, we do have a speed shear. The winds do increase with altitude. Let's see here. Instability about 1,000 joules per kilogram. Not too bad. There's a little bit of a warm layer there. I think storms should still be able to pass through that line because our level of free convection is a lot further south, than that line. So I don't think that's going to cause too much of an issue. Anyways, but when it comes to it here, we have that bit of a, kind of like a little pirate hook type of hodograph here, I always call it. So whenever you see the hodograph, so what the hodograph essentially is it's plotting wind speed and wind direction with altitude. That's what a hodograph does. It measures which way that the winds are moving, how fast they're going, and what for what levels of the atmosphere. So look at this. We have pink down here. We have red down here. We have green. We have yellow. So this is representing our height. So there's 12 kilometers. There's 9 kilometers. My head's in the way, but there's 8 kilometers. 6 kilometers that goes right on this line here. So you can see we go up in altitude, and that's correlated to a different color. And you can see on here, well, for example, yellow, we'll take for an example, that's our mid-atmosphere. Our mid-atmosphere is right here. See? Those, you can kind of color match those things. So that's in our mid-atmosphere. So picture this is a compass. We have north, we have south, we have east, and we have west, right? So in our mid-atmosphere, right at this level, which is, in this case, about between 6 and 9 kilometers, so 6 to 9 kilometers, the winds are moving northeast, and this brings us up to right around 60 knots. So you can see how we have 10, 20, 30, 40, 50, 60 knots it equivalents to. So 60 knots, look at that. We can verify right there. Yeah, right around 60 knots there. We got a triangle and a long line. A triangle is 50 knots. A long line is 10 knots. 60 knots. That lines up perfectly. And look at that. The wind direction's east. Isn't that cool? You guys didn't understand that? Like I said, it's literally like a compass. Literally like a compass. North, south, east, west. And, lower atmosphere, we'll use pink for an example. Starting off here at about, roughly about 15 knots, which we have a long and a short, which is 10 and 5, so 15 knots. And, you can see that the winds, they start off northeast, and then once we hit the red, you can see up there, it changes more eastward. And so there's actually other components that goes in the fact of it changing direction here, but, it's mostly off of that, which is pretty cool. So that's what a hodograph is. Anyways, but yeah, that's a subject for another day. Again, kind of me just getting off, getting off and out off topic here. But anyways, bottom line though, in this environment, like I was saying, for portions out there by like Kentucky, I think that theoretically we could have some severe storms out here as well if this can continue. This potentially could turn into not just a south threat, not just a threat for severe weather in the deep south like Texas, Oklahoma, Arkansas, Louisiana, but this also could turn into a potential severe weather threat for portions out there by like maybe even the western and southern Ohio Valley. I mean, that's possible. I think it's possible. So we'll just keep an eye out there for that. We'll obviously, watch this here for the next couple of days, and, we'll see how the models continue to handle it. But at least for now, that's what that is looking like. Yeah, this is forecast hour 99. So this is 99 hours out here. And our mid-range models, you can see, only go 84. So we're not quite to mid-range model support here yet. So that's that. Let's see here. Let me actually pull up. Look at this. So this is here for late Wednesday. Let me pull up like Louisiana and stuff. Oh, that's interesting. So there's a bit of a cap break there. Look at that. So you see that? The big blob there. So all this, all these parallel lines here, this is representing that we have a cap in the environment, which is basically that warm layer, that blanket that's preventing storms from happening. The cap is broken, according to this the NAM model here for late Wednesday, 21 Zulu. So what would this be? This would be, no, this would be like 4. Somewhere like late afternoon, we'll just say. Late afternoon here. Don't need to get that specific right now. But yeah, anyways, but it does show a bit of a cap break here. I'm just going to grab a sounding right here in the central side of the state. I mean, let's just see what this shows. Thanks for subscribing. Appreciate it. There is a warm layer, but there is still CAPE involved. I mean, there is still, the parcel. So that vertical movement of air, it will slow down a little bit. So we got some really fast, so we can actually measure how fast that, the vertical velocity is. And so it's going pretty fast here. And once it hits that layer, it's going to slow down a bit, but then it's going to pick back up once it goes up into the atmosphere, up to this level. That's our storm top here, EL, equilibrium level. So anyways, but in this environment, wow, okay, I just now looked at that hodograph. So there's a bit of a turn. You can see there's a bit of wind direction, directional wind shear there. Bit of wind, speed shear as well. The winds are increasing with altitude. But yeah, look at that. So that's what I was telling you, Roadster Jim. That's what I was telling you a minute ago. So in this case, you can see that there's a lot of there's a lot of directional wind shear. So in our lower atmosphere towards the ground, the winds are moving north in this case. And, you can actually see how the winds, they do change direction. as you go up in altitude here. So you can see how that's changing. So that's creating potential spin in the lower atmosphere, which, given the fact that we do have, some surface cape, which is our, instability at our surface levels, there is enough instability there. So in theory, it wouldn't be anything massive. I don't think we'd have any like big time tornadoes here, but I think we could have a couple isolated, weaker tornadoes in this, like I said, in this overall, in this environment here for possibly like late Wednesday. So, we'll have to watch out there for that. I mean, that's definitely is interesting. So who knows? I mean, maybe Wednesday could be added to the thread as well. I mean, there is a bit of a break in the cap here according to NAM. Let me see if that's been consistent. I'm going to hop to 12 Zulu. Oh, hold on. 0 Zulu is coming out actually right now. It doesn't quite reach that time. Okay, let's hop back to... Let's see, I'm going to bring y'all over here. Oh. All right, let's see. So that was 18 Zulu. Right at this point here, which is, let's see, 21 Zulu Wednesday. Let's drop down the previous run. 21 Zulu Wednesday. Yeah, there you go. There's a bit of consistency there with the NAM. The NAM shows the same thing on that model. So there's 12 Zulu run, and here's 18 Zulu run. You see there's a bit of a cap break there. Does that 060 go there? It does. But it's right on the edge of it, though. Yeah, I mean, there's a little bit of a consistency there. Maybe with a bit of a cap break here for late Wednesday. Kind of afternoon, I should say, Wednesday. So we might have some severe weather late Wednesday, too. We might have some severe weather then. So we'll keep an eye on it. All right. Does it matter which directions the winds? Let's see. Does it matter what direction the winds, different elevations are going? Yes, it does. You want them to mostly go clockwise. So, for an example, with our winds, you want that wind direction to change clockwise, essentially, as you go up in altitude. See, if it was counterclockwise, you really don't see a jet stream going from east to west. It's always from west to east. That gets into the big picture of things. The jet stream always goes from west to east, so it's usually always going to be pointing this way. I don't think I've ever seen an event, unless there's like no wind speeds, with the winds pointing that way. I mean, unless it's pretty rare if it happens, and even then, like the winds are pretty weak. But yeah, even in that point though, that really wouldn't do anything for tornadoes, especially if you have like the winds pointing south and even changing east, because you're bringing down cooler air from up above instead of that warmer air that needs from the south. So, but yeah, no, wind directions is very important, and you do want that winds to change. You do want that wind to change, mostly from northerlies to easterlies is what you usually look out for severe weather. There is an exception, but I'm not going to get into all of that here. The storm spinning counterclockwise. I mean, it can happen. Of course it can. Anyways, but yeah, we're just gonna drop that before we get way off topic again. I've already gone way off topic in today's live stream, so but I feel like it was pretty informative live stream today. I feel like I personally feel like I taught that pretty well, and I hope you guys received that information very well. I really do, because I feel like I did an above average of presenting that than usual. So yeah, usually I have a harder time teaching, but today for some reason I just kind of flew out fluently. I feel like I made more sense to some people today, which obviously good. That's obviously what we're here for. All right, let's see. Any update on my flight on Thursday? Courtney, yeah, so you are still in the risk for severe weather. Let's see here. Obviously there's no breakdown right now. Let me look and see when the cap theoretically could break out there. So 15 Zulu. 15 Zulu. 18 Zulu. Gotcha. When's 18 Zulu? Shoot, it's 4. Anyone know the conversion? See, my brain just doesn't work very well with conversion. So I know that 0 Zulu is 8 p.m. This is, let's see, hold on, it's 21 Zulu. So this is 6 hours before then, right? This would be like 1 p.m., I think. 1 p.m. So right around 1 p.m., it looks like the cap breaks in storms with fire. But like I said, take that with a grain of salt at this point. I mean, that's still a wide unknown factor, is what time these storms are going to fire off. But sometime, I'm thinking early mid-afternoon, at this rate here. Let's see here. Can I teach Enzo? I have on previous live streams, but I'm not going to do that right now. I did mention, what was it? The oscillations. I did actually mention that a little bit, in terms of El Nino, La Nina phase. Let's see here. I think we have a cap over Missouri. What, are you talking for Thursday? I think there might be some break in the cap on Thursday across Missouri. Let's see here. Oh, there we go. Okay. No, yeah. It's southern Missouri anyway. It looks like it might break the cap down there for late Thursday. Yeah, once again, we're also watching out there for some storms on for late Wednesday too. Late Wednesday and Thursday. Thursday's the big day as of right now, but Wednesday, I think possibly we could get some storms. But yeah, mostly Missouri is capped out though. Except for the southern side. I think you have the greatest probability in the southern side of Missouri here. Of course, that's one model opinion, though. Theoretically, that could change between the models and all that. Yeah. Yeah. I don't know. We'll see. Let's see here. Cape this year has been higher. It will continue to be higher than last year. I mean, Joshua, that's just typical, though. I mean, as we go into spring months and as we start to get things warming up, with the pre-existing cooler air in our atmosphere from winter months, the warmer air will have more of an interaction, meaning more potential energy and more Cape values. As we go in from winter, where it's all cold, to spring, where it's introducing more and more warm air into the previous cold environment, which creates more instability. So yeah, you can expect those Cape values to rise as we go into spring. Anyways, yes, Aiden is obsessed with Enzo. He likes climatology more, I'm saying. I'm more of I like the meteorology. I like the current state of things rather than like the future state of things, because climatology focuses on the big picture in a longer range. Meteorology is kind of more on the close range. Climatology predicts future weather patterns in the future, while meteorology kind of shows independent storms in the future. So there's a difference. Let's see here. Mid-latitude cyclones, yeah. Yeah, they're pretty interesting. Anyways, but yeah. So let's go and hop back over here to the risk area. Let's see, we'll bring this back up here. So once again, y'all, this is for Thursday. As of right now, let me just go ahead and make this clear. Well, hold on a minute. Oh, okay, there we go. Okay, so for Wednesday, day 4. So remember we were talking about Wednesday how there could be some severe weather. They have a tag called predictability too low. It says predictability too low, meaning that there's it's hard to tell right now what's going to happen. Which that's true. There's still a lot of things we need to learn about this event here. There's also something called potential too low, which it doesn't really show on this one here. It's all predictability too low. Potential too low would mean what you think. There's not potential for any severe weather. But in predictability too low, that means that once again, it's hard to tell at the current moment. So while there's not a risk for severe weather right now, that could change in the future. But obviously here for day 5, which is Thursday, Thursday is the big day, we'll call it the bigger day, with the possibility, of, I think, all hazards, personally. So with that increasing lower level jet in the later hours, it seems, the models were showing, we have all this instability, so the cap breaks, storms fire, and as we progress into the later overnight hours, those lower level winds increase, which makes me think that, well, I mean, if we still have storms firing at that point, with that increased lower level jet, that could allow for both damaging winds, and since we have directional wind shear, it could allow for some tornadoes, unfortunately. So we'll have to see. Yeah, we'll definitely have to keep an eye out there for that, and see how that progresses. Yeah. And a general risk for Thursday. There's no general risk yet. What are you talking about? Thursday, we have a percentage on severe weather. We don't have any thunderstorm risk. I mean, honestly, Misty, though, I wouldn't be surprised if you were. I'm just saying that there's no way to tell that right now. That only becomes available on day 3 outlook. Speaking of, I forgot to mention, day 3, apparently Tuesday, we got a risk for severe weather out there in western portions here of Missouri, which is interesting. Western, northeastern Oklahoma, and southeastern Kansas. Let's see, mass field thermodynamic details, blah, blah, blah. Let's see here. Oh, potential dry line. Interesting. Surface-based thunderstorms near the dry line / triple point. Let's see here. Hail and gusty winds. I'm sorry, I didn't mean to hit my mic, y'all. Hail and gusty winds, according to the risk here for Tuesday. Let me pull up the models for that. Actually, that's interesting. Might even have short range models for day 3. I think it's mostly day 2. I ain't too sure. Let's see. Let me pull up NAM. I think NAM should be able to reach it. Tuesday. Ooh. Oh, yeah. I see that. Look at that. Huh. That's interesting. Mostly capped, though. Mostly a capped environment. But it does have a break there for late Tuesday. Interesting. Let's see here. 850 millibars. Wow, I got a 40 knot lower level jet there. Interesting. 35 knot mid level. Kind of a weak mid level shear, but lower level's okay. Let me grab a sounding in that little pocket there. Take this with a grain of salt, guys. Let's see. Oh wow, yeah, we're riding close to that boundary. We're riding close to it being capped out there. Let's see. Yeah, very weak wind shear though across those levels. That's interesting. We do have a curvature. Oh, you can't see that. The hodograph is looking interesting. Yeah, look at this. The hodograph is looking interesting there. I don't know. That kind of caught me with surprise here. Let's see here. Let me do something real quickly. So our hail growth zone is the -10 Celsius line to -30. So we got to follow those isotherms. Following the isotherm, let's see from there. So that's roughly our hail growth zone. We do have a pretty fat amount of cape there, with some spikes in moisture levels. That could be pretty good. I think some hail, yeah, hail for sure in that sounding. Also D-cape, downwards convective energy. In the mid 700s. Wow. Interesting. Yeah, so damaging winds, I think, and obviously, hail, and in this environment, I mean, low end tornado can't be ruled out. But let's see how that materializes here. It's 48 hours out. Does RAP reach it yet? Interesting. Huh. That's really weird. Yeah, you can see that there's like a really thin line there of where the cap breaks. Does this model even show anything convecting out there? No. We do got a bit of convergence, though. You'll see that in the lower atmosphere. So, for example, that's where that environment is. So we have these winds moving this way, and we have winds moving that way. So eventually they'll converge, which in cases will allow for vertical velocity, for winds to move vertically because of convergence. So lift doesn't seem to be a problem. I don't know. It's just a weird environment. It's just very narrow. It's like We'll see. I mean, like I said, it'll be a lot better once we get like mid-range models on this, or sorry, shorter range models on this here. In this case, do I even dare just grab a sounding? Why not? In that really thin environment there. Let's see here. Wow, dude, our temperature is riding the parcel path. So in this case, I don't think anything would happen. We do have some mid-level instability. Pretty good, not gonna lie, but lower altitude. First of all, we have very dry environment. Our dew points in our ambient dry bulb are relatively spaced out from one another, which is indicating a very dry lower atmosphere. Which you need a lot of moisture in our lower atmosphere for one to get things going. Our storm base is extremely elevated here, so that would immediately cancel out any tornadic environment. If you have a storm base that's too high, tornadoes tend to have a problem forming. Let's see here. Yeah, that's just a weird environment, dude. I don't think that would happen in that though. According to this model, I mean, we'll see. All right. Let's see. Is Chicago on a day 4 risk? No. No, there's no areas in Chicago yet at risk. I mean, I don't even think Chicago will get impacted by any forms of severe weather. Let's see. Yeah, no, we're good. Yeah, Chicago's fine. While there is a few pockets of some instability south of Chicago, throughout like maybe Louisiana, I don't think it'll be anything organized severe wise. So I think we're good. Let's see here. Anyways, also let's go ahead and move away from severe weather for a minute. Let me hop you guys to the northeast real quickly because we do have a bit of interesting stuff going on here. We've got a lot of lake effect. Going on out there. Should clear by, let's see, what is this, Monday? No, it'll be completely gone by Wednesday across like all the states, I should say. But yeah, most of the lake effect goes all the way down here towards even the mid-Atlantic there. Lake effect will kind of end here. Yeah, probably late Monday, it looks like. Yes, lake effect. Yeah, so there's a lot of lake effect snow out there. Wow, this is a pretty... Dude, look how tight those ISO bars are. You see that? So this is our line, which is showing a constant of equal pressure. And the closer they are together, the more there's a steeper gradient of pressure, which meaning, in simple terms, stronger winds. Because look at those wind gusts. They've got to be pretty high because of those ISO bars. yeah, look at that. So wind gusts could be as high as like, wow, these are knots too. Some areas possibly in those upper elevations, maybe up to 40, 50 knots. It's like 60-mile-an-hour gusts. But for the majority of the areas, we're right around 40 knots. So about 45-mile-per-hour wind gusts possibly across some of those regions. Wow. I find it cool how the mountains block some of that flow. You see that? I think that's was that Mount Washington up there, and you got these strong southeasterlies, and they really like lower the winds on the southeastern side. It's cool. Yeah, I mean, it's just that's where geography and meteorology meet together. It's pretty cool. Pretty cool. Yeah, geography has a lot to do with weather. Of course it does, because mountainous environments can do a lot of different things versus, say, like Florida versus like Washington State. Two totally different environments out there. Let's see. Miss having big thunderstorms in North Carolina. Yeah, I hear you. I miss them too. I'm lucky though, because I did get a storm a couple days ago. It was pretty nice. We had a QLCS run through. It was a long line of storms roll through. Actually, this morning we had one too. It wasn't any lightning or thunder, though. It was just heavy rain from that remaining frontal boundary that rolled through that we covered the severe weather with. Yeah. Amazing lake effect. Lake should be frozen at this time. Are they frozen, though? I don't think they are. No, we haven't had many, like, super, super cold temperatures over these areas. Yeah, no, they're definitely not frozen. Even the air temperature. Yeah, so air temperature is directly influenced by... oh, that's so interesting. Air temperature is very much influenced by the water temps. And just know that air temperature can change a lot more easily than water temperatures. It takes a lot more energy and time for water temperature to change rather than ambient air temperature. Man, I just find that crazy. Like, look at this. So during the nighttime, let's see. So during nighttime, right? So morning time here, we'll use, I think this is like Michigan for an example. So 40-degree air temperature. And as we go like to the hot of day, look at this. 40-degree air temperature. The water is keeping it warmer during the nights and colder during the days. That has to do with a direct correlation of the water temperatures. It's cool because the water temperatures are influencing the air temperature above, which is very interesting. Anyways, what's up, James? Hope you're doing good, man. But yeah, I find that really interesting though, in terms of how that works and all. All right. Let's see. Oh, wait a minute. I didn't think about it. Yeah, HRRR shows that little Tuesday. Is that Tuesday? Yeah, late Tuesday marginal risk. I see why they put it there. I mean, obviously it's good to, have an area listed for potential severe weather, as theoretically it is possible. I mean, given the environment, we do have a thin, narrow line of a little bit of an open window for potential severe weather on late Tuesday. Which, I mean, yeah, it seems possible. See here, the model's really kind of depicted differently, but that's why we'll have to watch it and see. Yeah, I mean, winds in our lower atmosphere aren't too bad. Mid-level are pretty bad. So got a lot of lower level shear. But yeah, no, it's also very low in dew points. Our dew points are very low in this case, like lower 50s. So pretty low dew points, essentially. Anyways. Yeah. Now we'll watch, Tuesday, Wednesday, and Thursday. I think Wednesday will be added to some risk of severe weather. Same thing for Thursday, obviously. Thursday already has a risk. So Thursday's the big day. Wednesday is, we'll consider... Okay, so you go to a restaurant, right? You usually get served bread, and then you get served your appetizer, and then you get served your entree. So for Tuesday... This is our bread, okay? Wednesday, this is our appetizer, so mozzarella sticks. And then, Thursday is our entree, nice big steak. So you can kind of see how we got going on there. So, yeah, that's one way to put it, I guess. That's one way to put it. We'll see. We'll keep it on it, y'all. And like I said, we'll keep you posted. I just realized I have so many model tabs open. But we'll keep you guys posted. But I tell you what, y'all, we are getting close to, or we're already over an hour. So like I said, we typically only live stream for about an hour. Plus, it's getting a little late. So we're going to head off here pretty soon. We're going to go ahead and call it a stream here pretty soon. Yeah, we've really covered all we really need to regarding, the potential event. We went in the model. So if you guys are just joining us and would like to, see what's going on here, just rewind the stream to the beginning. I teach some things, I explain some things, and all that stuff. If you guys would be interested in, watching all that, it's pretty cool. Just rewind to the beginning of the live stream and watch throughout, like, because I go over models, I go over all kinds of stuff and stuff like that. So, anyways, but yeah, if you guys could, leave a like, be greatly appreciated. Subscribe if you haven't, be much appreciated, y'all. And once again, I really, really appreciate you guys very much. And, like I said, thanks for hanging out with us and all that stuff today. Let's see here. Cold core. Yeah. Could bust, could overperform. I think storms would be elevated in that environment, so I don't think tornadoes would be a thing. The more I think about it, yeah, it's a pretty elevated environment for Tuesday. That's why they mentioned tornadoes, because the storm base is going to be pretty high. Mostly elevated convection. So, yeah, I think it's going to be hail and winds, honestly, for Tuesday. If things can happen. And Wednesday, I think it could be a triple threat. We'll see. Thursday, I'm very certain it'll be a triple threat, especially with that increasing lower level jet stream in our later hours. You know, if we still got convection going on at that time period, then all that, you know. Yeah. Anyways, y'all. But yeah. But if y'all have any questions before we roll off here, feel free to let us know. We're not doing zip codes, though. So if you have a zip code, don't post it, because I'm not doing it right now. We're not going to do zip codes tonight. Whenever day 3 hits, so whenever this becomes, so not tomorrow but the day after, we'll do zip code forecasts and kind of show you guys where, because at this point, you know, this risk area is going to be changing a lot, considering it's still a couple days away, and you know there still is going to be some changes to the outlook. So if I was to give you guys this right now, it wouldn't be fully accurate, but day 3 is, you know, close enough to the event where I can start showing you guys where the risk areas will likely be. Of course, day 2, we'll have a breakdown and stuff like that. So, but anyways, when will it going it to it? What? Hold on. What? Teresa says, when will it going to it, Missouri? Missouri's probably not going to get impacted too much. Southern side, we have a little window open for, I think, Thursday. Pretty sure Thursday. We could have a little bit of severe weather out there in like southern Michigan. Sorry, not Michigan. My bad. Not Michigan. Southern Missouri. Yeah, there's a little bit of a window here for late Thursday. Maybe some cape with no cap going in that region there. It all depends. We'll see. Looks like Mississippi in the clear. Mississippi. Let's see here. I mean, we'll see. Thursday, we could have some storms out there. I mean, given the fact there's a cap break. We got weak wind shear, lower atmosphere. Yeah, pretty weak wind shear. I don't think we'd have any organized, super organized severe weather going on there. Let's see. Proxy says, thank you for all you do for us, Andrew. Hope your channel continues to grow. Thank you, Proxy. Appreciate it. Anyways. Appreciate it, John. Thanks, man. Appreciate it. And once again, Proxy, thank you so much for supporting us. You are awesome. Much appreciated. And you honestly help me keep going. Like I said, y'all's support is what helps me keep going. So Proxy, that donation that you gave us earlier really helped me out a lot. So thank you so much for everything you've done. You're amazing. I appreciate you very much, Proxy. You are a super supporter. We'll call you. That's your tag, a super supporter. And I'm very thankful for you. I really am. And you help keep me on my feet. You help keep me going, and that is very much appreciated. And I owe you so much. I do. I really do. And in which I have to say thank you for all that you've done. A big shout out goes to Proxy. Proxy is amazing. Our top supporter by far. And so, Proxy, you're very much special. So thank you so much. Let's see here. How about the fire risk? We do have critical fire risks. Yeah, let's see here. Let me pull up SPC. Actually, I'll bring it over here. Let's see, y'all. There you go. Yeah, so there you go. There's our fire risk. So Monday, Tuesday, Wednesday, we got 3 days of critical fire risks here. Wow, look at that. So that actually goes, wow, that goes through like the heaviest risk obviously is out there like towards Kansas, Oklahoma, Texas, northeastern New Mexico, also portions like east central Wyoming, southwestern South Dakota, and northwestern portions here of Nebraska. That's for your day 2 fire outlook. So yeah, tomorrow, right? Yeah, that would be tomorrow. See, Tuesday. Wow. Yeah, so day 3, day 4. Yeah, it's definitely interesting. All right, yeah, we'll keep an eye on it. I think that yeah, there could be some big issues here with fire coming up here too. Yeah, then we got marginal day 3, or sorry, oh yeah, day 3 for Tuesday, almost day 2. Which I think, just damaging winds and hail is a very small possibility. Still kind of need to see what's going on here, but like I said, storms should be elevated. Storms will be elevated Tuesday, which will prevent any like tornadic activity, I think. So I don't think we'll see any tornadoes on Tuesday. Hopefully, Wednesday, there's no risk for Wednesday, but I do think that there will be some organized severe weather Wednesday as well. Possibly all hazards. We'll see, and of course, day 5, which is Thursday, we'll have some severe weather all going on. Let's see, I'm proud of your channel growth. I'm proud to be a part of it. Thank you, Proxy. Once again, I appreciate you very much. You're definitely awesome. Let's see. Thanks, Haley. Appreciate it. Freezing temps here in Huntsville. Wow. Yeah, pretty cold. Pretty cold. All right, y'all. Yeah, we're going to head off here in a few moments. Let me go ahead and... I actually want to look at those temperatures real quickly. Yeah, we're going to look at the temperatures, and we'll head off here. Pull up our MEDAR here. There you go. There's our temperatures right now. So it's not quite freezing up by Huntsville, but it's cold. We're in the... Well, it looks like we're in the upper 30s, maybe? Lower 40s? Up by me, it's in the mid-60s, almost. Lower 60s. It does get pretty chilly up here. For once, we're mostly above freezing in the northern plains. That's interesting. Yeah, a lot of the northeast here is in the lower mid-20s up there, especially towards like northern New York State. Do I think the day fall will be extended north? I think it's possible, maybe a little northeast. But of course, that leads up to models, and if once mid-range models, stuff like that coming through, we'll have more of a higher resolution detail of what we potentially could see, and potentially more accurate as well. So we'll have to keep an eye on it. But I do think it's possible it could shift a little northeast for Thursday. Yeah. Anything under 60 is freezing, don't you know? Yeah. For me, it's anything under 50, honestly. I can handle the cold a little better than the warm. But anyways. All right, y'all. Well, I think we're going to go ahead and wrap things up here. Once again, I appreciate you guys very much for being here. If you've not already, consider subscribing. Leaving a like would be greatly appreciated. And once again, I appreciate every single one of you. Once again, Proxy, thank you for the 50. That is super sweet of you. Much appreciated. Big shout out for that. So thank you, Proxy. And thank you, everybody, for joining here. Thank you to our mods for modding the chat. Thank you, guys. Appreciate it. We had Catman here. We've had... let's see. I know we've had Brooklyn here as well. Courtney was here. I remember Mark. Did Mark ever join here? Was Mark ever in the chat? I don't remember if Mark was in here or not. But I feel like that was all of our mods. At least that I saw anyways. But yeah, you guys. Well, like I said, we're gonna probably head off here. Tomorrow on the table. I was planning on doing a video today, but that didn't work out because things came up here. Tomorrow, I'm going to do another live stream, of course, to prepare you guys, sometime probably right around, like, I'm going to shoot for earlier of a live stream tomorrow. Today it just kind of, came up kind of late. So, we're going to do ourselves another live stream tomorrow at some point. We'll keep you guys posted on that. And, you'll just pay attention. Like I said, that's the reason to keep post notifications on. So hit that bell. That way you guys will get notified whenever I do go live. Because, it seems like lately my stream times have been very inconsistent, so we'll definitely need to be aware of that. So turn on post notifications so you guys are notified. Anyways, y'all. All right, guys. Well, once again, thanks for joining. We're going to go ahead and head over here to the ending screen, my friends. Once again, I really appreciate you all for joining. Once again, big shout out goes to Proxy. Appreciate it. Once again, thanks, mods, for modding the chat. Of course, thank you to all of our members for being members. Appreciate you guys. And, of course, as a collective for everybody, thank everybody for joining us, tuning in here tonight. And once again, you guys are much appreciated. We love you guys very much. And, all right. Well, yeah, stream's going to head off here, y'all, in about 2 minutes, starting right now. So go ahead and say goodbye to your friends, family, anybody you're hanging out with, my friends. And all right, well, I think that's going to go ahead and wrap it up here for tonight, my friends. Once again, we'll catch y'all tomorrow at some point, sometime tomorrow evening, I'm thinking. So we'll be live then and there. But all right, guys. Well, y'all take care. Much love to you. And we'll catch you guys in the next one. Peace out, my friends. See you then.